Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, let us see the construction of Smith chart. We already know the relation between load reflection coefficient and load impedance as well as characteristic impedance. That is gamma L is equal to ZL minus Z0 divided by ZL plus Z0. We are going to take the normalized load impedance on Smith chart. That is small ZL. Cap ZL divided by Z0, right? I can rewrite the reflection coefficient at the load as ZL minus 1 divided by ZL plus 1. And we know that the reflection coefficient is a complex quantity. It has a real part as well as imaginary. So we are going to rearrange this expression so that we can write normalized load in terms of reflection coefficient. That is 1 plus reflection coefficient divided by 1 minus. Right. This reflection coefficient I am going to write as a real part and imaginary part. And this complete normalized load impedance, how can I represent it as a resistance plus the imaginary part is the reactance. This is the R circle and X circle that we are going to see in the Smith chart. So equating on both sides, okay, equating on both sides, okay. So we know the mathematical rule, right? There is a complex numbers are divided, so we have to multiply and divide it by this complex conjugate. For this complex conjugate is 1 minus gamma R plus J gamma I. So if I multiply and divide by the same and equate on both sides, we get what is R and what is X. R is the real part, X is the imaginary part. And after doing some rearrangement, we get the circle equations in the form of X minus X naught the whole square plus Y minus Y naught the whole square equals A square, where X naught, Y naught are the center of the circle, A is the radius of the circle. Here in my, I told there are two circles in our chart, right? One is the resistance circle, other one is reactance. So the resistance circle has the center at R divided by 1 plus R comma 0. There is no Y naught term here. Whereas the radius is 1 divided by 1 plus R. Similarly, for the X circle, the center is 1 comma 1 by X and the radius is 1 by X. Now let us see for various values of R, that is its ranges from 0 to infinity, what are the radius of this R circle and what are its centers. Corresponding radius and center we will find. Suppose let R equal to 0. If you substitute R equal to 0, means what happens? It is 0 comma 0 will be the center, radius will be 1. Okay. So 0 comma 0 means this is the center of this R equal to 0 circle. R equal to 0 is the outermost circle and it has a unit radius 1. Okay, similarly, if I want to find R equal to half, 0.5 circle means if I substitute here, I get what answer? 1 comma, that is 1 by 3 comma 0. That is the point here. Okay. Similarly, it's comma 0 and its radius is 2 by 3. To find R equal to 1 circle, if we see R equal to 1, you substitute, it is 1 divided by 2. 1 by 2 comma 0. So this is the center 1 by 2 comma 0 and the radius is going to be 1 divided by 1 plus 1 is 0.5. 0.5 is the radius of R equal to 1 circle. So hope you understood. Similarly, we can find the other circles. In the same way, if we do it for X circle, you can see that X ranges from minus infinity to plus infinity. Okay, reactance are both negative and positive reactance, right? Whereas resistance is only a real number, positive. So if we substitute X as 0, what happens? 1 comma 1 by 0 is 1 comma infinity. So for X equal to 0 circle, it's a straight line. Center is 1 comma infinity and the radius, if you substitute, it is 1 divided by 0 is infinity. Infinity radius means it will be a straight line only. In the same way, I can substitute X equal to 1. In that case, for X equal to 1, the answer will be 1 comma 1 is the center. Radius is 1 divided by 1. This is the radius of X equal to 1 circle. For X equal to minus 1 circle, the center will be 1 comma minus 1. Okay, because of the negative sign, we get 1 comma minus 1 as a center will be here, and the radius will be 1 only. Same in case of x equal to 1. Now let us see, these are the R circles we have computed, and these are the corresponding X circles. The X circle outside the gamma equal to 1, that is outermost R equal to 0 circle, we are neglecting. So if you see here, putting all together, lines of constant resistance circle is complete circle is this R circle. Reactive circle is not complete circle. We are neglecting the portions outside gamma equal to 1. Okay, and we will have one more lines of constant reflection coefficient, and that we have to draw. It will not be present. So question of all these only we will get a Smith chart in this manner. So we normally use a black mark design Smith chart for our solving the problems. Okay, so I have given you the link to download the same from the website. Hope you understand how the Smith chart is constructed. These are the R circles. Okay, these are the X circles. Yes, outermost circle is R equal to 0. And this is X equal to 1. I think you're able to see. Here X equal to minus 1 we have to take into consideration. Here negative sign will not be mentioned, since the same chart can be used as a impedance chart as well as admittance chart. Hope you enjoyed the session. We will meet next time by looking into various scales that are available in the Smith chart, and then we will start doing the solving the transmission line problems there. Thank you everyone. Happy learning.